So I hope you can see my Knime platform. Yes, is it visible? Is my Knime platform visible to you? Yeah, I didn't save my project, so I'll try to do it again. I'll explain it again. So yesterday we were doing the random forest method and we used a very important data, which is the iris data set. So first I need the file reader node. I take the file reader node from my repository. I give a new name for this node, which is called the iris data. So that is the very first step. Now I have to configure my node and I have to import the data. I right click, I configure, I browse for the data where I've located in my computer system. I search for it and I import the data. Now the data has been imported. I click apply, I click OK. Now you can see that there's a change in the signal color from red color to yellow, which means the data is ready to be executed. I right click and I execute. Let me check my data output. That is, I have to right click and I have to check the file table. So when I check the file table, I can see that the data is pertaining to iris data flower and it has four different elements, four different attributes. Iris flower has been classified into three varieties, that is iris setosa, iris versicolor, and iris virginica, based on four important elements. What are the elements? Sepal length, sepal width, petal length, and petal width. And the class also has been predicted by this data scientist. But apparently we don't know whether this is true or whether this is false. So that is why we use a random tree mode to predict different decision trees, to also to check the accuracy. So the data is good. Now let me take the next node. So what is the next node which we have to use? We have to use the partitioning. So any type of machine learning, you have to split the data into learning data and training data. So that is why we always use this particular node, which is called partitioning. So 80% of the data is training and remaining 20% of the data is testing. So I give a name to it, 80% training and 20% testing data. So now I have to connect my file reader node to my partitioning node. Now let us configure the partitioning node. I right click and I configure. As the default menu, you can see that the data has been split into 70-30%, which means 70% of the data is training data and remaining 30% is test data. But what is the rule of thumb which we have to follow? 80-20%, Pareto rule, right? So Pareto rule is nothing but 80-20%. So this relative percentage for partitioning, I change it from 70 to 80. And I click apply, I click OK. Now you can see that there is a change in the signal color. Let me execute it. Now, can you tell me what is the next node which we have to use? Yesterday, I taught you. First, you have to train your model. Your model has to learn, and then only it has to predict. So what is the node which we have to use? Exactly. Random forest learner. Very nice. So please go to your node repository and type random forest. Random forest is nothing but it is a collection of multiple decision trees, right? So you can check the accuracy and you can very well depend on that data to take strategic decisions for your company. So when you type random forest in your node repository, you'll get random forest distance, random forest learner, random forest predictor. But what is that basic thing? Only first you have to learn, then only you can predict. Yesterday I gave you an example. Astrology as a course has been introduced by many universities. So people who are interested in astrology, just like that, they can't predict. They have to know, different positions. We talk about sun sign, we talk about moon sign, we talk about, the different planets position. You learn about the basics, then only you predict. The same concept has been used here. You learn, then you predict. So please use your random forest learner node. right? So now you have imported your random forest learner node. What is the difference between random forest learner and predictor? How come? After such a long debate, you're asking this question, very much surprising. Without learning, how can you predict? Random forest learner node will have the ability only to learn. Random forest predictor node will have the ability to predict. So both is not the same, right? So now you have imported your random forest learner. Arvind, it's so surprising that you're asking all these types of questions. What is the difference between random forest and decision tree? A collection of decision tree is called random forest. I've been talking about this for ages together. What is this? For 6 months, I take business analytics, and finally, you ask me a question whether I was the coordinator of Become Morning program or, Become Honors program. It's like that. Please listen. Okay. So now, what is the next step? I'm going to give a new name for the random forest learner. I'm going to give a name learning model or learning data, anything which you can give. So now you have to connect your partitioning node to your random forest learner, right? And at the same time, remember, you also should have a random forest predictor. Both you should have. If learner is there, then predictor also should be there. So I'm going to give a name predicting model. So we have the learning model and we also have the predicting model, right? So now one more string from the partitioning node should be connected to the predicting model. And now you have to connect your random forest learner to the predictor. Why should you connect your random forest learner to the predictor? Because the predictor cannot predict without learning, right? So that is why you have to connect your random forest learner to the predictor. Are you clear with this? Can you confirm in the chat box? Okay, now let us configure the random forest learner. So when I click configuration, everything is going to be a default menu. I'm not going to change anything. See, previously I told you we have supervised learning. We also have unsupervised learning. In supervised learning, I will be giving all the important instructions. In unsupervised learning, I will not be giving the important instructions, right? So now this is just the default menu. You leave it as such. You execute it. Let us configure the random forest predictor. So please right click. You can see again, I'm not going to do anything. I'm just going to click OK and I am going to execute it. Now, after you do this, you have to check the accuracy, right? How will you check the accuracy? What is the node which you have to use to check the accuracy and confusion matrix? Yeah, scorer node, exactly. So please type scorer in your node repository. Please take the scorer node. I'm going to take two scorer nodes here. I'll tell you why. One scorer is used to check the accuracy of the learner model. The other one is used to check the accuracy of the predictor model. Both I want to check. So I'm going to connect my random forest learner to scorer. And at the same time, I'm also going to connect my predicting model to the score. So I'm going to give a name for this. Accuracy on learning model. I want to check whether my model has learned properly, right? Whether it has the capacity to predict. So that is why I want to check the accuracy. Now, I want to check whether the predicted model, the predicted output is accurate enough to take good decision. So again, I need a scorer node. So let me give a name for that. accuracy for predicted model. Are you clear with this? So let us configure this. Right click and please do configure. Yesterday I taught you one important term which is called class and out of bag class. What do you mean by out of bag? It has other names called bootstrapping, boosting, and also to remove the error, right? So before you check the accuracy, you have to use the out of bag method to reduce the error so that it improvises the accuracy score, right? So you do that configuration, you right click and you execute it. After you execute, this is the output. What is the output? You get the confusion matrix and also the accuracy matrix. So first, let's check the accuracy statistics. So when we check the accuracy statistics, the overall accuracy statistics you can see here, it is 0.942. So when we talk about 0.942, it means that the learning model is 94% accurate, right? And you also have a reliability value. That is Cohen's kappa. Cohen's kappa is a reliability test. When we use SPSS, we always use Cronbach alpha, which means, what do you mean by reliability? The data which I collected is reliable enough. It doesn't have error. It doesn't have missing value. It has authentic information. It has very genuine information, right? So that will check the reliability. Accuracy is nothing but the accuracy of the model learning, the ability to predict or the ability to learn. And we also have the reliability. So you can write a very good inference for this. How will you write the inference? Iris data set, which had 150 samples, was used for the random forest prediction. The data scientists have initially programmed the system to learn and then it has predicted. So the accuracy rate is 0.942, which is almost 94%. So the learner model has well understood the input code which has been given by the data scientist, and then the reliability is also good. So when you write the inference for reliability, you have to tell that Cohen's kappa, which is a reliability test, shows a significant output, which is almost 91%. So 91% is above the threshold limit. What is the threshold limit for reliability? More than 0.7. Any aspect which is more than 0.7 is considered to be highly reliable. So which means this iris data set doesn't have any missing value. It has been very neatly collected without any error. It is error free and this can be further used for the prediction. This is how we have to write the inference. And now we also have to check the accuracy for the predicted model. So how will you check the accuracy for the predicted model? So you have to first execute the scorer node, right? So you can see here, one should be a class and the other one should be a class prediction. You can ask me a question, why should we choose the class? What do you mean by class here? The data will be classified into three different polarity. What are the three different polarities here? Iris setosa, iris versicolor, and iris virginica, right? That is a class which we have to predict. So now the first column should be class and the second column should be predicted class. You are requesting the decision tree model to predict the class. Initially, when I taught you about the cluster analysis, we clustered the data. But is that clustering correct? Is it accurate? Can that be used for further decision-making process? So that is where you need a random forest to predict the accuracy. So you click apply and you click OK. You execute it and you check the outcome. Outcome is again the same. we have a confusion matrix, and we also have the accuracy statistics. Now let us check the accuracy statistics. So you can see the overall accuracy. The accuracy is 0.933%, which is almost 94% or 93%, which has a very good accuracy rate. So which means you have to write the inference in such a way the input data which has which has been programmed to be learned and which has predicted the class, that is the number of classification, is accurate. And we also have the Cohen's kappa, the same inference you can write, that is almost 89%, almost 90%, which is above the threshold limit of 0.7. So which means the model has predicted very correctly. But now let us also check the confusion matrix. Yesterday, I taught you about the confusion matrix. Confusion matrix is bifurcated into 4. That is true positive, true negative, false positive, and false negative. Right? You have predicted that 50 flowers, which has a similar characteristics, has been classified under Iris setosa. Remaining 50 has been classified under Virginica. Remaining 50 has been classified under the other particular category. But you can also see in reality what has been predicted, right? So you have to use the same concept of confusion matrix, which we learned theoretically, to write the inference. You can also check the confusion matrix for the learning data. So you can see here, learning data, see how it has been bifurcated. Learning is different from predicting, right? So you can see the difference in confusion matrix. So I'm giving you a small recap. We use Iris data set. You have to split the data into training, and then you have to split the data into testing. Then you also need a learner model. You have to train your model. You make your node to learn what is needed and what has to be predicted. After learning, you have to use a decision tree predictor. And we will also be using out of the bag mechanism, which is nothing but it is called a bagging mechanism, or it is called a bootstrapping, or it is called boosting, or it is also called accuracy enhancer. It will enhance the accuracy of the data, input data, which has been fed into the computer. And we can also check the accuracy statistics for the learning model and also for the predicting model. The very first, what should you do? This is an example where we have not done anything, right? Whatever we have was the default we have used. I will begin only based on two variables. What are the two variables which I can take for doing the prediction? I can either take sepal length width, I can petal length and petal width, or I can take only sepal length or only sepal width or only up to my choice, right? Again, I'm telling you, in the first way of prediction, we have used the default menu, which means we have taken everything. Can you see this? So we have taken the inclusion criteria as sepal length, sepal width, petal length, and petal width. All the aspect we have taken. But now I want to use a regression model. Regression will find the relationship between two variables, right? And it will also predict. So now what is the node which we need? We need a random forest learner, but it should be a regression. So go to your node repository and type random forest. So when you type random forest, you can see this random forest learner regression. Can you see this? So I take that random forest learner regression. Now let me ask you this question. When you have the random forest learner regression, what is the other node which you should have? You look into your node repository and tell me. You have the random forest learner regression. Very good. Random forest predictor regression. So when you have the learner, you always should have the predictor also. So you also take the random forest predictor regression. See, the first instance, we used a learner model and the predictor model. Now we use again the learner model and the predictor model. Both we have to use, right? So the same way, whatever you did, I'm placing it in the same position. Okay. Now again, I'm going to give a name, learning model, and this is going to be the predicting model. What is the difference between both? First, we have not done any type of tuning to the data. There was only a default menu, right? I have not supervised it, but here I'm going to supervise. I'm going to take only one particular category. So again, I'll be connecting my partitioning node. So are you able to follow? Are you able to follow? Same way, how you connected your unsupervised learning model, you connect your supervised learning model also. Same. Okay. Now let us configure that. Now, how do we configure? Okay. Now right click. Okay. Right click, go to configure. And after I type configure, I can see one option here. I'm going to take this petal width. See, you can see here what is the target column which I want. You can take anything. You're free to take anything as a data scientist. You see, just remember one thing. You can have 4 different models here. One separately for sepal length, one separately for sepal width, one separately for sepal length, and one separately for petal width. I told you before, random forest is a collection of decision trees. When you take a decision, you can't depend only on one model's accuracy output, right? You have to have multiple. So for now, I'm going to take this petal width. You can also take multiple things. Multiple things is also possible. And I'm going to click apply. I'm going to click OK, and I'm going to execute it. Okay, wildcard, let's not get into it now. That's a separate domain. I'll tell you later. So now, have you done this? You can take anything. Don't depend only on this one. You can take anything. Or you can have one more random forest learner regression for sepal width and one more random forest predictor regression for sepal width. Again, you can draw. So you can, elaborate the model. And now let us configure the other one, that is a random forest predictor. So configure. Now when you configure again, you don't have to do a lot of changes. You can just apply and you can just click OK and you can execute. Have you done it? Have you guys done it till now? Can you let me know if you guys have done till now? I hope you all have done it. You are able to follow it. Okay, now let me ask you a very simple question. Okay, now let's check the output of this, the prediction output. The prediction output again has multiple elements here. It has the sepal length, sepal width, petal width. But in the regression model, you can take only 2 variables basically, right? So now I want to predict one with the other. So I have to filter my data, right? I have used only petal width. and I want to filter the data. I don't want to take the other types of elements which I see in my data sheet. So to filter your data, what is the node which you have to use? I'm showing you an output here. Your output has all different elements here, but I don't want all the elements. I want only my petal width as a regression variable here. So what node should you use to filter the other types of column elements? What is the node which you need to filter the other column elements? Because you have to concentrate only on, no, you have to concentrate only on petal width. Think and tell me. You have to use the filter option and then you have to take only one particular item. What is that? See, petal width is your target variable. The target variable, based on the target variable, you're going to predict the petal width, actual petal width you're going to predict. You'll be using a column filter. Column filter node, I've already taught you. So take a column filter node. Let's configure, you'll understand. So when you configure, it will be having all the elements here. Can you see here? Sepal length, sepal width, petal width, class, prediction. But what is that one thing which you need? You need only your petal width, and you also need your other important one, that is prediction, that is petal width prediction, right? Click apply and click OK. Execute it. Check the output. See, for performing my regression, I've taken only this variable, that is petal width, and only this element is there. I want to check only for this element. I want to check the accuracy only for this element. So now to check the accuracy, what is that node which you need? What is the node which you need to check the accuracy? Scorer node. Very good. So now take the scorer node. But you will not use the scorer. You will use a numeric scorer. Can you see this numeric scorer? You take that numeric scorer and you connect it with your regression model. Let us configure and check. So now we have petal width, petal length prediction, and then you execute and you check the statistics. Okay. See, you take a numeric score, both you can take. You can also get a confusion matrix, accuracy also you can get at the same time. We are going to use a regression, right? What do you mean by regression? Can you tell me? What do you mean by regression? I've already taught you classification and regression. What do you mean by that? Regression is the statistical modeling. It is a statistical process for estimating the relationship between a dependent variable, one or more response variable, right? So that is the basic meaning of regression. Often it is called the predictors. So when we talk about that, the regression, you have to check the statistics. So check the statistics here. What all you get. So we'll write an inference for this in the next class. Mean absolute error, mean square error, root mean error, and you also can see the regression. How accurately it has predicted. 99% it has predicted. See, okay. See, that is why I told you the accuracy of the model can be predicted using any variable. You are supervising. So when you supervise, I'm going to take only two important variables. That is, now for now, I'm going to take only petal width. You can take sepal length or sepal width, and you can also check the same. Okay, let us do that. Let me take the random forest learner regression again. And again, let me take the random forest predictor regression again. Let me take the column filter again. And again, I need a numeric scorer. Okay, now you also take like this, right? So now I'm going to again connect my partitioning node. Then I'll be connecting again my partitioning node to my predictor model. I'll be connecting my learner model to my predictor model. Then I'll be connecting my predictor model to my column filter, then to my numeric score. But what is the variable which you can take? You can take, instead of petal width, you can take sepal width. Apply, okay, execute it, right? And again, in this, you can configure and you can again execute it. And now in the column filter, you tell me when I take last model, I took only petal width. Now I'm taking sepal width. So what is the configuration which you have to take here? Can you tell me correctly? Can you tell me? I have to take sepal width with sepal with prediction, right? Apply, click OK, execute it. Check the output. Out of everything, you have taken only these two, sepal width. And now you can configure. So again, apply and check your scores. So you see the regression statistics is just 0.491, right? But when we use the petal width, it was 99%. So how easily you can conclude, right? You can tell that the model is more accurate when you take into consideration to classify the data only based on petal width and not based on sepal width. So likewise, you can use all the four different dimensions. You can check all the output, and then you can come to a final conclusion. Are you able to understand? So column filter node is basically, see column filter. Okay, directly you can go to column filter. I'm sorry, I think the mistake here. So from the predictor, I go to the column filter. Yeah. I click execute. I click my output. Same it is there. So how easily you can, how nicely you can, do the predictions. So that is why I told you in decision tree, you will be having only one output. But in case of a random forest, you get an opportunity to get multiple decision trees with multiple output, right? So based on the attributes, you can better classify the data. You can also use the scorer node and you can also check. So are you able to understand? Can you just let me know if it is clear to understand? Can you type in the chat box? I want to hear from your side. And one more thing, when you use the scorer node for the random forest predictor, the accuracy statistics will be very comparatively, not correct. What is that? What question is that now in the chat box? Sir, if we connect column filter or random forest predictor, it is the same. Yes, it is the same, but it is better to connect with the learner model only. Everything is the same, but it's usually better to connect with the random model, right? So accuracy also you can check, and you can also predict the confusion matrix. Now, what I want you to do, I've mailed you one wine data, right? That wine data, you use it for clustering. So I want every one of you to please take efforts to do decision tree and also random forest method for wine quality prediction. Wine quality prediction, I'm sorry. So I hope you have received the data. Next 15 minutes, I'm going to give you. Please make use of this 15 minutes. Open your Knime platform. I think you are already using your Knime platform. Please run this again and please check. Next class, we'll be writing the inference for this. So please save this model, right? Please save this model. See, save as. I'll give a name for my model, confusion matrix 1. Okay, and let me save it. So you also save it and keep it. Now I want you to use all these features and see for the next 15 minutes. Are you clear with this, guys? Are you clear with this? You please take a photo or a screenshot of this. Please take it. I hope you have taken it, right? Oh, let me only take it and I'll mail it to you. I'll mail this to you. So please check your mail and let me know if you have received the output. I mean the screenshot of the output. Yeah, now you can check. You would have got it, right? Yeah. So please practice it again. Okay. Yeah. So that's it for today's class. 15 minutes. You please practice. Thank you.